Okay guys, now we're going to talk about dividing radicals. So let's start with the easy one. We're going to take the cube root of 64x to the 6 divided by y to the 12th. Now what we do here, we notice we can't really simplify anything under the radical. So we're going to break this into two parts. We're going to have the cubic root of 64x to the 6 divided by the cubic root of y to the 12th. As we learned earlier, we talked about earlier, the cubic root of 64 is simply 4. And then remember, we're asking ourselves, how many groups of 3 do we have of x's? We got 6, so we have 2 groups of 3, which gives us x squared. In the denominator, we ask ourselves, how many groups of y do we have? 3 do we have in 12? That's 4, giving us y to the 4th. There is our simplified version of the original cubic root. Now let's look at one that might be a little bit more complicated. This time we're going to start with 2 square root of 64x to the 5th over the square root of 2x to the 3rd. In this case, I can notice that some things can cancel. So what I might want to do before I get started here is to put it into one radical, or one square root, 64x to the 5th divided by 2x to the 3rd. Notice we can simplify 64 over 2, because 2 goes into 2, 1, 2 goes into 64, 32 times. That's going to give us a new radical, 32 over 1. And then with the x's, the x to the thirds cancel out, leaving us simply with 2 in the numerator, so we get x squared. Now we can take each part separately. The square root of 32, however, they don't have a square root of 32. But there are some numbers inside of 32 that we can break, factors inside of 32 that we can break apart. We can get the square root of 16 x squared times 2. 16 we can take the square root of, 2 we cannot. X squared we can take the square root of. So we simplify, we take the square root of the part we can, which is going to give us 4 x square roots of 2. Now you may be wondering, well, Dr. Ed, what did you do with this? Well, notice this is the square root of 1, and the square root of 1 is simply 1. So the value here would be over 1, but it's understood to be over 1 anyway. So this would be our simplified expression of that one. 4x square root of 2. Let's do one last example. This one's going to be a little more complicated. I don't want you to think I'm giving you all the easy ones. I'm going to do a 4th root. And what we have here in our 4th root is 3a to the 6th, b to the 5th, divided by 16, a to the negative 2, b to the 13. Yep, I threw that negative in there, so bear with me. The first thing we have to do is simplify what's under the radical. We can't do anything with 3 and 16, so we're just going to leave them in the radical as they were. A to the negative 2, if you remember correctly, simply means that we're bringing this value, it's in the wrong spot, we're going to bring it up to the top, so now we have a to the 8th in a numerator. These can cancel, b to the 5th, b to the 13, when that cancels out, that leaves us simply 8b to the 8th in the denominator. Now we're going to break this up into two parts, because we have the fourth root. We're looking to a fourth root, and we know we can't take the fourth root of 3. So we're going to do the fourth root, and we're going to break it into two parts. The fourth root of a to the 8th, because we can take the fourth root of that. We can't take the fourth root of 3. We can take the fourth root of 16. The fourth root of 16 is going to be 2, and we can take the fourth root of b to the 8th. So now we have our simplified version. We're going to come over, and that's going to give us the fourth root. How many groups of 4 are in 8? That would be 2. And then we can't do anything with this one, so we just bring it over. The fourth root of 16 is 2. The fourth root of b to the 8th, how many groups of 4 do we have in 8? That again would be 2. So this is our simplified version of our original expression. If you have any other questions, you can ask me tomorrow. Hope this helps, and I'll see you then.